Well, I suppose it's time to get this show on the road. I hope that you all like cubes. Because you're in one? That doesn't make any goddamn sense. I feel like these stream introductions are getting worse and worse as I spend less and less time on them. But yeah, hey, let me switch over the little stream layout things here. Hey, there we are. So today we be talking about cubes. Bro reacted to his mind. And anyway, today here's was it unlike anyway, here's Wonderball. Anyway, here's bromine. Melts your face off. Throws pocket bromine at you. So yeah, today this is not the video we're reacting to, but it will make good background music as I start the introduction. This is the video we'll be reacting to today. So, second time this channel gets reacted to on stream, returning guest, Tom Explosions&Fire, aka in this case Extractions Ire, his second channel. He is deciding to make a lot of bromine because it is, well, to dive into why, we do have to back up a little bit. So he embarked on a project in 2022, I believe, to make the molecule, well, the big cube molecule I have here shown on the right. Don't mind the methane. The methane's not important yet. He wanted to make this cubane derivative, called 1,4-dicarboxyl cubane. And he wants to make this because it is something that kind of is inherently a little bit fascinating to chemists. Or he wanted to make this because it was inherently a little bit fascinating to chemists. This doesn't automatically loop, I have to manually do it. It is interesting because it has all these hard 90-degree angles, and each of these corners, I see that, you know, we're not all experienced as chemistry as I am, and that's great. I like to talk about chemistry. This is my one chance to talk about chemistry, and people might actually be interested in it. Each of these corners represents a carbon with 2 hydrogens coming off of it, and then they're also connected to 2 other carbons, so they kind of form 4 bonds around each carbon. I'm really not organized today. My brain is, I can't even remember what I was just saying. It's fascinating for that reason, and the carbons are arranged in this kind of hard 90-degree angle shape between each other. And that is interesting because normally carbons like to take up 4 bonds and have this 120-degree angles between each bond. That's just kind of where it got comfortable. Thank you, Grim, for the suggestion. I did not know that was a native YouTube feature now. So there's a very immense amount of strain within the bonds of this molecule, which for a channel named Explosions&Fire is interesting because bond strain means that the molecule has a lot of potential energy pent up in it, and if you do some extra chemistry on it right, you can get something that's pretty explosive. It's a lot of energy to release all at once. And it's just also plain interesting to get carbon in these weird bond angles. So it's a difficult process to actually synthesize these kinds of molecules because of the weird bond angles. Not only is it that you're putting, you know, one face of a cube into a weird strained 90-degree angle square, you're doing so with 8 of them, and like that's just nature is saying, no, I don't want to become the cube. Don't put me in your tungsten cube, please. But humans, crafty bastards that we are, have found a way. And he's following a couple of papers, or he had followed a couple of papers to make the cube. He successfully did it in, I believe, late 2024. But he got kind of a very small amount, just a couple milligrams of it, and not super pure. He wanted to do better. So, with this, the end of 2024 and into this year, he wanted to repeat some of his steps to make a lot more of the cube, so that way he could probably have enough to do a main channel video about how you can make it, like, go boom. And that's fun. Let's see, what do the angles have to do with the explosions? Why they break, when they break, they explode? So it's that, like I was, so I probably explained it poorly because my brain's all over the place right now, but it has to do with how carbon bonds. Okay, carbon itself basically wants to make 4 bonds. It wants to, and with those 4 bonds, the best way to arrange those bonds so they aren't getting in each other's way is to be at 120-degree angles to each other and making a tetrahedron. The tetrahedron being like a triangular pyramid. If you just stack 4 triangles to make a pyramidal shape, that's a tetrahedron. And the bonds want to repel because bonds fundamentally are, I'll just draw an example, they're fundamentally are just 2 electrons that are kind of being shared in the general space between 2 atoms. And electrons, being negatively charged particles, don't really want to be near each other, except in this case of 2 forming a bond, but that's kind of like getting into quantum chemistry stuff, and we don't want to get too deep into that right now. But, suffice to say, electrons like to pair up, but they don't really want to have multiple bonds overlapping each other, because then that's just a mess, and the negative charges want to repel. And so carbon normally wants to form 4 bonds at 120-degree angles to each other, but having them in this cube structure puts them all at 90-degree angles to each other, except for these like kind of weird one-off little spots, which have this carboxyl group that's separate from the cube, but is part of the synthetic process. So each of these, I actually misspoke earlier, so each of these corners represents a carbon with 1 hydrogen sticking off of it, not 2. And so you get kind of these wide bond angles from the other carbon-carbon bonds to the hydrogen, but you end up getting these 90-degree angles between given carbon-carbon bonds. And that produces a lot of strain, much like if you were to try to bend, like, say, pieces of plastic into this cube. If the, say, pieces of plastic would like to form a ring shape, but you kind of bend it into a cube, you can feel there's that tension in the cube. The same kind of thing exists for this real cubic molecule. When you break those bonds, that tension releases because it doesn't want to be at 90 degrees. It wants to be at 120 degrees. And so that helps bolster the energetics if you make the compounds even more explosive. Negative atoms attract the positive ones. I mean, that's how ions work, but that's not, I'm not needing to be dismissive. I have some... This is one of my problems with pedagogy, is that I try to not be dismissive, but I end up saying things that sound condescending. I'm really trying not to be. But no, that is true. Negative atoms do attract the positive ones, and that's like for salts, like sodium chloride. You have your sodium plus and your chlorine minus; those attract to each other. And this is kind of just a discussion on, just electrons in bonds and how they repel and such. But yeah, so why the hell is this guy making bromine to make this? There isn't even any bromine in this structure. Well, I'm going to let him mostly explain his synthesis pathway, because he'll probably start talking about it more. But it's basically just part of the synthetic chemistry to actually put these carbon-carbon bonds together. You can't just, smash a bunch of graphite together and expect it to all come together. It basically involves putting carbon-bromine bonds on something first, and then doing additional chemistry to get the carbons to attack the carbon-bromine bonds, in a sense, push the bromine out, make the carbon-carbon bond, and, kind of trick nature into making a cube by allowing other favorable reactions to occur. It's kind of putting energy in so that way you can get energy out, kind of deal. If you hear what I mean, you gotta spend energy to make energy, right? So yeah. So pedagogy is like the philosophy of like teaching. Like, how do you teach good is basically what pedagogy is meant to mean. The study of teaching. But yeah, so I think that's enough waffling around, but that's the premise of the video. Why he's going for all this, why he's making a whole bunch of bromine, which bromine, I remember your comment earlier there, Radio Bit. Yeah, bromine is a pretty nasty chemical. It is one of the few liquids at room temperature In fact, it is the only... It's not the only. It's one of only 2 elements that, in their pure form, are liquid at room temperature. The other being mercury. And like the other liquid, like mercury, it is also highly volatile, in the sense that volatile means it is very prone to evaporating. So even though bromine is this dark brown liquid, it fumes a lot. It makes a lot of gas, and it is, for various chemistry reasons, mostly bromine wants another electron. It doesn't want to be in this bromine-bromine bonded state. It wants to ionize to form bromine minus, which would have 8 electrons around it. Whereas in this case, it kind of has 7 as a bonded bromine molecule. It's got 3 pairs of electrons, and then these 2 electrons in the middle are shared. It wants another electron. It wants to form 2 bromine minuses, and so it kind of viciously attacks everything. And bromine is really good at corroding skin, corroding metal, reacting with other organic compounds, like wearing away at like plastics. Really, the only thing it doesn't like reacting with is like glass and maybe like certain like clays, concretes, that kind of thing, metal oxides. It's liquid bromine is not something to be messed with, and there's a good reason that this guy is making it. I trust this guy to make it because he does have a PhD in physics, so this is a professional doing it. Chemical physics specifically, so he's not just like, you know, bashing cars together and being like, ooh, me like chemistry. But he's worked with it before. But, you know, if you don't try this at home, kids, I don't think anybody was going to do that, but I should say that, you know, it's not... I still wouldn't make bromine at home. It's a bad idea. It's not good for you. Yeah. Hey, Bingo Bongo. Nice seeing you again. I was just finishing up explaining the premise of we're making cubes. There goes your Saturday. Uh-oh. Crash Icarus cannot be held liable for any of the decisions that you make on your own time. But yeah, so I think with that, let's cut the ambient music and let's actually go ahead and get into the video. I'm excited because this guy is also funny. He likes to talk about dumb shit posting. It's great.
Good day, welcome back to another episode of Big Cube. The series where we're trying to make 1,4-dicarboxyl cubane from household materials, and we're trying to make a lot of it. Made the cube before, didn't make very much of it.
Oh yeah, I should also mention, just the little side thing, his joke of now available at Bunnings. He wanted to do a little bit of a challenge when making this cube molecule for the first time, and then also making it again here. Bunnings is a local Australian hardware store, and so his challenge to himself was try to make the cubane molecule with as many chemicals from the hardware store as possible, or to say it better, without purchasing like good quality or special chemicals off of like eBay or Alibaba or something like that. He wants to actually, make it from things that are easily and sustainably sourced from his local hardware store. So it's a fun little extra challenge.
Now we're trying to make a whole heap of it so that everyone in the world gets a little bit of cube. That's not what we're trying to do, but we're trying to make a lot of it anyway.
But everybody deserves a little cube.
We successfully completed the second step and made the key towel, this molecule here, and we have it in this container here. Look, this is our key towel. So I'm not going to stop and explain every single part of the steps that he has here because we would be here all goddamn day, going from like fundamental levels of chemistry. But yeah, suffice it to say, this is like he starts with one eBay purchase of this adipic acid, and then does some heating under some base. It causes one of these oxygens to swing back around and drive off the other oxygens in the area, making this cyclopentyl ketone molecule. Adds ethylene glycol, makes this kind of protective group, so that way the bromine doesn't absolutely destroy the molecule in the next step. And then this is where the bromine comes in. Well, this is the step where the bromine comes in, and that's the... he needs to make the bromine, and then maybe he'll also do the step to make this next organic molecule
here today. I don't know. It's a 40-minute video. We'll see how long he takes to make bromine. And then there's further steps, but those will... I'm sure I'll probably end up reacting to other videos in this series as he makes them more, so, like, we'll have time another day to discuss all that. Giving everyone cube, my brother, we already have Minecraft. Yeah, but I'm a secret Minecraft not enjoyer, so I prefer these cubes.
Means today we have the bromination step. Step 3. Last time we ran
Everyone
this bromination
deserves
step, it
a little bit of
worked
hazardous cube as a
somewhat
treat.
well, I would say. Somewhat well. We got reasonable
You're playing
yields,
Minecraft right
probably
now.
not great
You
yields,
didn't need
but
to
it
tell me
did
that.
work first time. However,
okay, no, all right, side tangent time. No, I'm actually not super into Minecraft myself. It's Minecraft to me is a little bit boring, I'm gonna be honest, because I need more objectives and action with my games. Minecraft is very much the game for people who just kind of like to sit back, chill out, and like completely turn their brain off and just kind of like, oh, let's do some crafting and maybe a little mining, and oh no, the zombie's hitting me, I'll hit it back harder kind of thing. Like, that's oversimplifying it, but like, the easiest way to say is I'm just more of a Terraria guy, because Terraria is a lot more combat-oriented, and, like, there's clear goals and objectives to go do. That's not to say that when I play Terraria, I completely ignore making my base beautiful. I actually bother to, like, make real homes for all of my NPCs, unlike a lot of other despicables who play that game who just give everyone, like, fucking wooden tenements. But I primarily focus on, like, the action-adventure fighting part of the games, and, like, Minecraft just doesn't service that for me. It just, like, kind of falls a little flat in that, like, just combat depth area. It's just like, okay, you use the shield, you hit the guys, you maybe pull out the arrows, and if you're, like, really into it, you pull out the splash potions. Like, okay, cool. Do PvP? Like, no, that's not me. So, like, yeah, I don't know. Minecraft doesn't really do it for me. I can sometimes play it when, like, my friends are making a server, but other times I'm just like, honestly, you know, I'm just here for the vibes, and I'm kind of just, like, not here otherwise. Crash doesn't like Minecraft. Audience unsubscribes. Yeah, it's, you know, why you booing me? I'm right. Terraria's your jam. Combine it with Mega Man. That would honestly be awesome. I'm sure there's, like, a Mega Man mod out there for Terraria. I'd probably hop on that. I haven't done much modding for Terraria, surprisingly, but, like, I think it would be good to do. I've been meaning to, like, do a modded playthrough, but every time I think of it, it's like, oh god, I have to search for mods and put them all in, and it's too much. Fair, but you're not happy about it? That's okay. You don't have to be happy. You will have your own Minecraft, and you will like it. I will have my Terraria, and I will like it. You only play Minecraft when you're either making pixel art or recreating Doom maps in it. Yeah, it's for... Minecraft is much more for the creatives who really want to dig into making their masterpiece in, like, voxel art style, but I don't know, for me, I'm just like, I don't know. I want to do other things when I play video games. You're a despicable, everyone be living in a wooden box with a table, chair, and a torch. How could you? How could you? With all the free healing, well, not free, but, you know, good healing the nurse gives you and all that great advice the guide does, you could at least give them, like, a humble granite home. Never understood Minecraft PvP. When you were younger, you're into it, but not no more. Yeah, I never really got much into PvP either. There's a couple of FPS games I like, but I don't really like getting too sweaty about it, and most PvP just turns into very, very sweaty gameplay. Not my thing. Hearing Foxes makes me want to play Ion Fury again. Never heard of it, but it has the word ion in there, so I'm like, ooh, that's good. That's chemistry. Hey, speaking of chemistry, let's get back to this chemistry stream. Am I right, guys? But digression over. Had to get that off of my chest.
Reasonable yields, probably somewhat well.
I think
this container
let's
here,
recap.
look, this is our key towel. So that means today we have the bromination step. Step 3. Last time we ran this bromination step, it worked somewhat well, I would say. Somewhat well. We got reasonable yields, probably not great yields, but it did.
You didn't poison yourself, so that's
time.
good.
However, the key thing is last time we ran this bromination, it was really the first time where it kind of scaled down a lot. We made a reasonable amount of key towel in the small scale synthesis, 40 grams or something like that. But by the time we did step 3, this bromination step, we only had a couple grams of the tribromide, so this tribromo species, which is what we need to make here. Obviously, if we're trying to make 100 grams of cubane, which is our plan, we need a lot more than a couple grams of tribromo ketal here. I have some numbers somewhere of what we need to do.
Can't you just hit it with the size enlarging gun? It'll make it bigger.
This is
more,
the biggest
more cubane.
scale I think we can manage. I have some new 2-liter flasks, so we're going to be running this in a 2-liter.
I also like how this man has decided to take his difficult chemistry notes on what looks to be like a scrap of a scrap of like an index card. It's a really good aesthetic.
Flask, are you ready? This is all the stuff
we
need.
need.
We need 130 mils of the ketal, which we've made previously. We need 110 grams of 1,4-dioxane, which we make from ethylene.
I think I'm actually convinced that in the corner might just be a legitimate scan of what he has in his hand, actually. I don't think anybody else would bother, like, no one would bother to make, like, a specifically shaped, like, edges like that. I think that might just literally be a scan of the card he's holding.
Glycol, we will need to make that. We need 800 mils of DCM and 167 mils, which is 520 grams of bromine.
Oof.
Altogether, it's
much more bromine than you should ever handle.
Like that. But given the density of dichloromethane and bromine, it's a big mass of product. But if we pull this off, at this scale, we'll have a lot of tribromo. But pulling it off is not particularly easy. There are several issues here. How do we get enough of all these chemicals? Well, there's a good and bad thing about this list. Let's start with the good one. The good one is we made enough ketal. Really, in the last step, but
chemistry works.
Using it all up in this reaction, which might come back to haunt me. We're going to use it all up, and that will be 130 grams of ketal. No.
Surely he will get a complete conversion. Surely he will not only get like 30% yield and crush his own dreams. This would never happen.
Don't worry. So we can strike that off the list. We've already got that. The dioxane, we'll come back to the dioxane because the bad news really is the bromine. It's a lot of bromine. This amount of bromine is not easy to make or handle.
No.
But I'm actually going to do something a bit weird in this intro here. I'm going to break tensors because I've actually done this step already. Oh, where is it? I should really put gloves on for this. Let me put gloves on. Look at this fucked bottle of bromine.
That is... Oh... That is both like there's two parts of me. There's the one part of me saying like the full chem academic, which is going like, wow, that is so hot of you, dude. You have like a full jar of bromine, like take me now. The other side of me is saying, dude, what the fuck are you doing? This is like so hazardous. You could even see the top of the lid is like starting to have like a little bit of an outer, like an out dent. It's starting to eat through the cap a little bit already. This is not safe. You should not have this. Ugh. It's great. Don't know if it's cosmic fate or just sheer coincidence, but after you reacted to Nile Red last week, 2 other YouTubers you watch had Nile Red clips in them. Huh. How about that? Like, it's good that I'm not alone then. A lot of other people love, I mean, it's fair, right? Nile Red's a huge YouTuber. Like, he escapes even the chemistry tuber sphere. Like, the dude has, like, gets, like, 8 to 10 million views on an average vid. Like, a lot of people love him. So it totally makes sense. And I'm glad that other people like him, too, you know? It's good to at least get some people talking about chemistry.
It is terrible quality, but there is
not everyone does,
300 mils of bromine in here, which is over a kilo of bromine. So this is enough to run this reaction. It's actually enough to probably run this reaction twice. This would have been pretty hard, pretty unsafe, and also kind of really boring to make all of this on my own. But luckily, I had some help from fellow chemistry YouTuber, Mr. Green, if you could believe that.
We are going to be making a ton of bromine.
Oh my god, that guy's tall.
That's our goal.
If we do it good. Which maybe. We're 50-50. Yeah. First time. Have you ever made bromine before? You made bromine before.
Before, just not this much.
Yeah,
forbidden Tabasco sauce. Yeah, that'll literally burn your tongue right off.
What could go wrong? I will ask, but that I'm going to say it's a rhetorical question because there's multiple things that can go wrong.
Yeah.
So as much as we are going big scale, we're going to have to really do it.
Ice will solve everything.
Yeah, and we got to not like drop the bromine, drop a whole liter of bromine on the concrete, at any point. We got to avoid that.
The concrete will absorb it and react with it. It's fine.
This bromine with the goal of making 1 liter of bromine in a day. So that's nearly 3.5 kilos of bromine. And for that, we needed to convert.
Just look at the. I love that about bromine. It's just like, it's a liquid, but you're going to see the fumes everywhere. It's going to coat everything that you are like trying to contain it in. God, the fumes of bromine are just so threatening on their own.
Over 5.
I wish there were more colored gases that weren't like extremely deadly. Basically, any gas that you can see has some kind of big health problem with it. Chlorine is a, deadly green gas for all the same reasons. There's like a blue gas out there that's like some kind of oxidizing nitric oxide species, and like all the gases are like deadly. all the pretty gases are deadly. It's such a shame.
Kilos of sodium bromide. It was a bit of a task, I gotta say. We spent all day distilling bromine, first in the 1 liter flasks and doing it on a sort of a smaller scale, though still in a 1 liter flask, and then we moved up to the 2 liter flask. What is this? Why are you shaped like that? I don't know. And we were running a 2 liter flask at the same time as a 1 liter flask to try and produce enough bromine and get up to the 1 liter mark within the day.
Well, Grim, see, that's the even funnier part, though. Like, yeah, I guess it would be more fucked up if all the deadly gases were transparent and undetectable, but also, like, it's also just true that a lot of deadly gases are still transparent and difficult to detect. Carbon monoxide is your key example of that. People get poisoned by carbon monoxide so easily because it's invisible and it doesn't like necessarily smell like much. It kind of has a smell, but by the time that it's like concentrated enough that you could smell it, you're probably already in a very bad situation. The stonefish of toxic gases. I'm not sure. I don't remember what you mean by stonefish, but sure. I definitely agree.
And we were a bit rushed for time because this bromine stuff doesn't really want to be rushed. It's also quite unsafe, so we had to take our time with it. Now, we used a bit of a strange method to make the bromine. You can make bromine a variety of ways. Previously, I've made bromine using peroxide as the oxidizer, so you've got a bromide, salt, and acid, and hydrogen peroxide. People have used potassium permanganate. You can use a lot of other things. But in this case, we wanted to use calcium hypochlorite. This is a strange choice because generally people avoid chlorine-based oxidizers because you can make this interhalogen compound BRCl. So it's 1 bromine and 1 chlorine.
Which, that's, as I'm sure he's about to explain, chlorine and bromine gases on their own are very reactive and bad for you. The interhalogens that are like just one halogen bonded with another halogen are often also explosive and unstable, as well as being extremely toxic and corrosive. It's a very bad idea.
And that is pretty much a gas. And you'll lose some yields to that, and you also contaminate your N-bromine with this bromine-chlorine molecule. However, you've got to remember we weren't prioritizing yield or purity in a sense. We were aiming for that 1 liter, so what we were actually prioritizing was speed, ease of doing it, and also cost, because you can buy a lot of calcium hypochlorite for very cheap. So we optimized for speed and cost rather than yield, which looking back, maybe
not a good idea. That's never a good idea. You don't optimize for speed and cost.
And I think that was in part because of so much BRCl that was produced. It generally produced when there wasn't very good stirring, but when we were working in this 2 liter flask with
just makes your life more difficult when you have a giant amount of impure crap to purify.
Oh yeah, because it's got the sodium bromide.
It's kind of caking up on the top there.
I'm worried it's just going to go...
Yeah, you're right. I didn't expect it to cake so hard.
Oh. Yeah, because we
stonefish, invisible killer. Nice to know.
Still
that does describe carbon monoxide well.
In a day of bromine.
Are you serious, dude? Are they really just doing that? Oh my god. I mean, sure, they're outside. That's not... For anybody seriously contemplating making bromine at home, no, don't do this. Do not measure it out that way. That is a terrible idea. You need to measure your closed glassware weight first, and then just measure it inside of that. Although that doesn't seem to be a measuring plate, that's a stir plate. So what the hell are they even doing? Why are they just stirring this out in the open?
100 mils in a day of bromine. The obvious question, of course, is why? I've got a reason for making bromine, but why did we try and make a whole liter of it? What was Mr. Green's motive? Well, I mean, you might guess that he just wanted to make a very big bromine volcano.
Oh, they just wanted to have fun.
Reacting with the aluminium.
That's
make a video
why.
up on his channel about making this
God.
bromine vortex, but I got to keep any leftover bromine. Watch it.
Now, okay, admittedly, that right there is why I love chemistry. The fact that you can explain why that happens and predict that that happens and make that happen again. But there's a limit of, like, I'm not doing that kind of thing at home. That's, God, that's a terrible idea without, like, a proper fume hood to exhaust all that.
This looks so fucked is because, I, like, poured back a lot of the bromine that we had reacted with the aluminium. It had got hot. It's got dissolved aluminium bromides in it. But it was all this bromine. I wasn't going to let all this bromine just evaporate off. I need it for the chemistry, so I saved it.
What? Why would you not? Oh my god!
Pouring skills aren't.
I have to watch that again.
Chemistry, so I saved it.
That's like, okay, the safety professional in me is coming out. That's like four bad ideas all in one. Handling bromine out in the open atmosphere. You couldn't have been fucked to get a funnel to pour it into the beaker. Now you have everything is stained with bromine and is just putting off tons of toxic and corrosive everything everywhere. And like, why are you trying to harvest like a little bit of extra from like the residue that you have left? You should have just did the math first and was like, oh yeah, I need like this much bromine to react with this much aluminum. You could do that. It's not hard to do said math. It's less fun, but like if you need to conserve it for what you need to do. Oh my god.
Stop. Sorry, my pouring skills aren't.
I can't believe they're this calm. Yeah, why women live longer than men. You're so right.
So, it's pretty contaminated. So we will just have to redistill.
Oh, now
it.
he gets the funnel.
Bromide in there, I think it should cause any BRCl in there to just form BR2. So we should be able to clean up this bromine. Importantly, there's enough of it. The bromine goes on the pile with the key towel. And I will mention, I just have the dichloromethane lying around. I have about 800 mils of dichloromethane lying around. I used to get it from Paint Stripper. That was how I got it over the counter. I bought 2 liters from a chemistry supplier a little while ago. It's a little bit of cheating, but I do have the dichloromethane.
To be fair, he, with his own little challenge there, so normally he has shown off in videos before that he got dichloromethane by buying some paint stripper at his hardware store that comes in this kind of like awful gooey kind of canister, and then having to distill it in a distillation apparatus to collect off the dichloromethane on the other side, which works and gets it pure, but it does also take a lot of time. So it's kind of interesting that he can also just purchase dichloromethane directly. I don't think I could actually do that in America anymore. I don't think that with the EPA's regulation from last year, I don't think you can actually do that because they made it so that like it's basically banned from all consumer use. So yeah, I guess the perk of living in Australia.
So this leaves us with only one chemical left, and then we can do the bromination reaction and finally make a lot of tribromo, keep moving along this big cubane synthesis. So let's do some chemistry. All right, here is some
cubes.
glycol and
well, wait, hold on,
acid
not cubes
heating
yet.
Up. It's just gone this weird piss color, as things always tend to do. It was this, you know, dyed green color. I'm just using the ethylene glycol straight with some sulfuric acid, and this is the dioxane forming reaction that I've never really quite gotten a hold of, and I've done it quite a few times, so it's a little bit embarrassing, maybe not embarrassing, frustrating is maybe the word, that I haven't been able to really master it. This is Extractions Ire, so I very rarely master anything. Put on some staring. The point is this reaction kind of gets out of control for me. It looks, I mean, piss coloured now, but it will go all tarry, and at some point that tar will foam, and quite a few times when I've run this foam kind of blows through the system and ends up in your beaker, and Yeah, I've got footage of that.
Oh my god, poor Beaker.
Times. This does seem like a problem with this reaction. The sulfuric acid and the ethylene glycol eventually break down to just form long polymerous tarry carbony masses. It's a reasonably common home chemistry reaction to do because you get one.
But Australia is kind of a hardcore PvP zone, more because of the animals, I guess. I don't feel like it's resource rich. You know, it's not the environment that's difficult. It's all the other players. You know, the man's comedic editing is on point. He is. That's why I love this channel so much. He is very, very funny, all things considered. Anyways, I'm faffing about over here trying to like think of the reaction for how to show how this reaction's supposed to work, because I'm not sure he's actually going to show it on screen. But it basically works something like this, where the sulfuric acid provides the acidic hydrogen plus to the ethylene glycol, which would then absorb it, or well, not absorb it, but one of the OH groups bond to it. You end up getting something like this. OH2, which is, hey, that's basically a water on the end of the molecule. That would, in fact, like to leave. So if another ethylene glycol molecule shows up and loves that one very much, it will go ahead and do what is called a backside attack to make the water molecule leave and replace it, which I'm running out of space here, but then that goes ahead and forms something that looks like this. HO. So let's see, we got this bond here, and then another one here. H. And then that's another carbon, OH here. Right. So it does that. We now have this kind of plus species. And through basically repeating that again, dragging the hydrogen over here, and replacing this OH or that OH with one of the other ones, kicking the other one off, you basically end up forming this dioxane molecule right here. So that's how the reaction basically works. But as he kind of explained, if you keep this reaction going for too long or have the conditions just wrong, you can basically just end up building chains of these together, and you just kind of get a awful plastic mixture. And that's not what we want, and there's no real good way to recover yourself from that. So I'll just kind of summarize by multiple steps pointing to that. And there we go.
Which is reasonably useful out of something that's very, very commonly available and cheap, which is this car coolant ethylene glycol. So, right, you've got these ethylene glycol molecules, and you need to get two of them to kiss. You know what I mean? You get two of them to kiss, and it.
Hey, he made the kiss joke. I made the sex joke. Oh wait, no, he also made the sex joke.
Two of them to kiss, and it releases some water. Right, this is weirdly getting erotic already. And once we've connected two together, we've got to do that again.
Chemistry's so erotic.
Because these ethylene glycols are already attached, it's easy for it to close in on itself. So actually, the really smart way, and a few people suggested this, the really smart way of running this reaction is to not start
I don't think it counts as yaoi or yuri. They all identify as theys, actually.
All you have to do is kind of close these two in together. The problem is getting diethylene glycol is a lot harder. It does appear in some products, but I wasn't able to find any around the place. Ooh,
yeah, you're not getting no diethylene glycol. That's a difficult one to grab.
Interesting. Anyway, some other
Tar
people
vision.
think that running a lot less sulfuric acid
yaoi, that works.
Really
I'll accept that name.
And it kind of makes sense. So this is 200 grams of ethylene glycol plus 20 grams of sulfuric acid. So
forgive me if yaoi is an already established term. I don't read fan fiction.
Not super high, but reasonably high. And then what I'm going to do once it's hot, which is just about now, it's starting to get even more piss colored and starting to just start to boil. I'm going to dump in another 200 mils or 200 grams of ethylene glycol. And then as we're running this reaction, I'll just keep dropping in more ethylene glycol. So we don't boil it down and start really increasing that concentration of sulfuric acid, because I think that's what happens most of the time as well. As we're distilling off the ethylene glycol as dioxane, the sulfuric acid concentration is increasing, and then it kind of reaches a point where instead of just linking two of them together, it links them in long chains or just dehydrates them all together. You know, it's just pulling off waters randomly from ethylene glycol and forming carbon and tar. So
I have no fucking clue what he is talking about. Okay, I have a little bit of a clue, but like I have no fucking clue if what he's describing matters at all. I think he's just he's doing his best to try to troubleshoot here and make it so the acid concentration doesn't get too high, but I also feel like maybe having higher acid concentration would prevent these giant chains from forming because it kind of breaks things up, or maybe it would cause them to more to form. I can't fucking tell you. So I guess maybe because like intramolecular stuff is faster, so maybe if you have just these like real short chains forming and like no other ethylene glycols to come in and, you know, come in and kith over here, like maybe the molecule will react with itself and force out the water and you'll get your desired product and that's all good. But like this is why it's the alternate channel. He doesn't have to script these very thoroughly. It isn't, you made it up. Well, it's a good term you made up then.
That's what we're going to try and do. I'm going to have to do it immediately and stop yapping because this is getting hot and this stuff isn't even connected. So, enough yapping. Let's mix some more chemicals up.
I do also like his determination to say that, like, there's no way that the dyes or whatever the hell else is in my coolant is possibly affecting my reaction. Nope. It's gotta be these weird concentration kind of things, which he might very well be right. But also, maybe it'd be best if you don't have, like, green dye in whatever you're working with. That could interfere with things, but fuck it. We're using hardware store chemicals. We want to do this fast and loose, right? We want anybody to be able to make a cube for themselves. Oh no, don't. Look, I felt it. I felt the earth shake when I said determination too. Don't get Alphys and Toriel and all their friends in here. They weren't invited to the chemistry party.
All right, I've been at this all day, and
they're over at the biologist club down the road.
I won't get up here and complain. We've gone through the whole bottle, really, of this, which is fantastic. I really actually, on my scales, only weighed out to be 940 grams, which is well short of a litre, but it's probably actually on my scales for being out, although that is out by a long way. Anyway, I'm collecting a little bit more piss still got that to add. It is getting tarry. I caved and added a bit more sulfuric
We have the
acid.
three colors of human fluids: piss on the right, shit in the middle, and then question marks on top. Would maybe that's like a green? That's like phlegm. That's the fourth Greek humor. That's phlegm.
It's just too slow. Yes.
Incurred undercover defective. There's not a fucking chance he would click on a chemistry video. Don't worry. This is our safe space from channel enemy undercover defective. He would never watch chemistry. I know him very well.
If we really reduce the sulfuric acid level, but it is a lot slower, so really you can add heaps of sulfuric acid and just do it fast and loose, and then you have to baby it along to make sure it doesn't foam over and ruin everything, or you can add in a little bit less and, you know, it takes longer but you don't have to monitor it as much. So I don't know which one's better. I've been here quite a bit just watching the sun move across the room.
I feel like so, Tom would go with the one where you have to baby it less because
yeah, we'll
likes
end up
doing
with
that.
quite a bit of liquid. The next step is to put in quite a bit of sodium hydroxide, which will separate the dioxane in the water and also polymerize a lot of impurities that are in there, like acetaldehyde, which is
and
quite
then sulfuric
prevalent
acid that comes
in
over,
this
neutralize
as
it.
well.
That helps.
Great. Okay, that's it. That's the whole update. Thank you. Thanks for tuning in.
You're
All right,
welcome.
this is our tar that we have that contains our dioxane. It's not meant to look this bad. I just got it wrong slightly, this procedure. You do add sodium hydroxide into the dioxane to make all these impurities tar out and separate the dioxane and the water. But really in the procedure you run another distillation first before adding the sodium hydroxide to remove most of the impurities before doing this sodium hydroxide bit. So
that would in fact make sense. If what you have mostly is impurities that will tar up and you add the thing that makes tar crash out, if you do that, well, then you're just going to get tar with other things in it. You now made impure tar rather than dioxane with a little bit of tar.
So this is what happens when I don't triple check my, my reference material and the procedure before starting and thinking.
Well, it's
I
a
just
simple
remember
enough
everything
mistake.
correctly. It's fine. Our dioxane should be fine, but I was a little concerned because
The edit NaOH. How's she going to be a member of the mag mammal community now? I'm sure she'll make a full recovery, right? It's like when Germa got hit with 7 trucks. Oh no, sorry, that was Star, and he recovered within like 2 days.
I remember adding the hydroxide previously, and it goes a little red or something like that, but it's never gone this like black color. But that's usually because we throw away most of the acetaldehyde, which is a byproduct of this. So we throw that away in a distillation first before adding the hydroxides. I don't know. The dark stain should be fine.
Light brown is kind of oddly delicious. It's kind of Dr. Pepper looking though. I like that.
Azeotrope. I am worried that our yields will be very low because of the small amount of sulfuric acid we used. I don't think now that I've done it, it worked very well just because it didn't produce the dioxane at really a high rate. So I'm worried that we distilled over a lot of the ethylene glycol. So a lot of this volume of liquid is water and ethylene glycol and not a heap of dioxane, which would really suck. But I suppose we'll find out. I won't get all doom and gloom ahead of myself here, but that's something that I'm worried about.
Turns out this video is all about trying to make
let's get this set
dioxane from engine coolant rather than making a whole bunch of bromine.
Because why not?
He really pulled a clickbait bait and switch on me, huh? It's still kind of neat though. Maybe this is arcane knowledge I will need one day. Trick your friends by replacing their steak sauce with bromine. For legal reasons, this is a joke. I mean, theoretically, you could be cooking your steak with bromine. It is an oxidizer, like oxygen. Just heat it up. That could cook it. You poison yourself with, like, weird brominated organics, but you could cook it. Ooh, spider. Spider alert. Spider is going to die of bromine poisoning.
All right, the distillation
like a real patriot.
It looks like we've just hit 100 degrees, so the temperature was at about 85, and then it stopped, and then the temperature went up again. So that's it for our dioxane. Surprisingly early. Well, maybe not surprisingly, but definitely disappointing.
Getting more and more confused about his dioxane.
But it looks like we've distilled all the dioxane and water azeotrope out. So this is roughly 70% dioxane. We tried to convert a whole litre of ethylene glycol. It should be alright, it should be enough for what we need. Maybe, just enough. But yeah, this method I tried to do to improve yields has absolutely cooked the yields. We're only like 2 or 3 videos into the series, and I've already generated several monumental tars. I mean, look at this. Look how thick this sludge is. I've got to clean all this shit, and I'm ignoring it because I don't want to.
It's like a demi-glace.
134 grams of water and dioxane azeotrope. Not only is that absolutely abysmal yields, but I don't think it's enough for what we need.
Well, Tom, look at the bright side. You get to try this again.
In the cupboard, I think from the last time
we I was just going to use it once.
Reaction, we probably recovered some. So that should get us over the line. There is, what, approximately 60 mils in there. All right, so we'll combine all our dioxane, water, azeotrope, and add some sodium hydroxide. We want to neutralize any remaining impurities and also drag out the water until its own layer. So
I hope it doesn't just turn into tar again. They still had even more to crash out. That would be so sad for him. Oh, that's sad for him. That's a lot of junk. Oh, he did the classic blunder. Joint stuck. Now he's got to, like, heat it up. Oh, no, he just had to give it some elbow grease. Oh, true. It is kind of olive oily. If your olive oily also had, like, cockroach poop in it.
Here, our dioxane, it is reasonably dry. All the water has been removed. There is probably still some dissolved
reasonably dry, you say?
Water and dioxane have a lower boiling azeotrope, so as long as we throw away the first stuff we collect, that should have all the water in it.
And protein. It adds protein, too.
From then on, we'll get as dry dioxane. Now, usually what people would do here is to dry the dioxane with sodium. And I wasn't going to do it. I wasn't going to do it because it's not really in the spirit of this series. We're trying to use chemicals from the hardware store, blah, blah, blah. But it is a safety reason. I'm worried about peroxides in the dioxane because there was sort of a 2-week lag between making the dioxane and running this distillation. And what happens is if there's peroxides in there which form from oxygen in the air and exposure to light and that kind of thing, they're not usually that dangerous, but as we concentrate it down, the peroxides can concentrate and then explode at the end. I have a little bit of sodium.
Yeah, actually, let me elaborate on that point a little bit. This is an actual safety concern in my job that I have to look out for every once in a while. So, oh wait, this is a little bit loud in comparison to some of the other music. There we go. So, Oh, I'm also realizing Vtuber needs to be refreshed. Hold on 1 second. There we go. Okay. So, what he's talking about here is that with this dioxane molecule, dioxane over time, with exposure to oxygen in the air, will start to form organic peroxides that look like this. The reaction pathway this goes through is something along the lines of, let's see, you have hydrogen here. So I believe last week we talked a little bit on oxygen radicals. Speaking of any more progress on the Vroid model, sadly no. Hopefully some this weekend. I don't have a whole bunch of like things to do with like thumbnails to make and what have you, so I might be able to actually get around to working on the shoe again. I really am hopeful that I get to work on the shoe again. And actually finish that up a little bit. Hold on, how do I draw this oxygen correctly? There we go. Because the shoe is, again, it's the main thing that's like keeping that Vroid model in limbo. Eventually it'll get done, but eventually keeps on not coming. I'm a little bit cynical of the prospects of actually getting the Vroid model done before ASIN comes up, but you know, maybe not. It's really always depends. The shoe, thought you were going to prioritize the top half, or is that done already? The shoes are the only thing that, the only thing that requires, like, heavy Blender custom usage. Basically, the rest of the model is done. The hair is done, the outfit's done, I mean, there's maybe, like, a couple of things, like, I want to make, like, the pants pockets actually maybe have some three-dimensional characteristics, but that shouldn't take too long to correct in Blender. It's mostly making the damn ZX shoes, because Mega Man ZX has weird shoes. They're cool shoes, but they don't have many things that like easily kind of like, oh, just a couple modifications and it's perfect kind of thing. So I have to kind of finish making that. Now, of course, most people aren't going to see the shoes during a stream, but I want to use the model for things other than just, you know, sitting and playing games. So I want that to be done as well. But yeah, so it's progress eventually. Hopefully it'll get done eventually. But anyways, returning to the reaction. This is kind of going back to what we were talking about last week with Nile Red's video, talking about free radical reactions. So if we have the 2 electrons in this carbon-hydrogen bond over here, that would want to, no, it doesn't want to, but the oxygen itself really wants to react to make sure that it's free unbonded electrons on it, because oxygen naturally exists as a diradical and is also why oxidation and like within the body and on like your car is kind of a big issue. The lone electron really wants to pair up with another electron, and it'll just kind of smash and grab and, you know, burst other bonds selfishly for itself. So you eventually end up going over to get an intermediate species kind of like this, where you have 1 free electron now on this carbon over here, and then a oxygen species that looks something like this. There we go, and then the remaining unpaired electrons will pair up with each other and form something that looks like this. This is a very slow process because you can kind of see there's a lot of awkward reactions that have to occur. A not super angry, but kind of angry lone electron has to try to break a bond off of another organic carbon-hydrogen molecule, and then like the other side has to flip around and bond together, which that just doesn't happen, geometrically speaking, all that often. So it's a slow reaction, but over time, you can get a buildup of this. And the reason that this is dangerous is because the oxygen-oxygen bond itself is really weak. And if you have too many of these molecules heated up together, the oxygen-oxygen bond itself will break, and with that bond broken, that releases a lot of energy, and enough of those molecules together, you have an explosion, which is not good. So he's talking about basically trying to do some tests and dry things up so that way that problem doesn't occur. And you know, good on him for thinking of safety now. The fact that it didn't occur to him earlier when just, I don't know, pouring bromine into a flask without a funnel, that's a different question. But, you know, safety works on different levels for different people. But anyway, he's going to go in this with drying it with sodium, and I'm not necessarily sure what the drying part is important for, because that's not going to get rid of the organic peroxides, but let's hear him out. Let's let the man cook.
And the sodium should destroy the peroxides, and then I'll just feel safer about this. I'm not going to compromise on safety.
Well, I mean, I guess so. Sodium is a reducing reagent, and these peroxides are, in fact, oxidizing agents, so I'm not sure how the actual reaction looks, but I guess that you would have sodium and its free electrons able to interact with this somehow, and, like, then, oh, look at that. This turns everything back to normal. Hooray. Good job.
So we're going to put the sodium in, the sodium react
bromine,
with the water
true.
and any, peroxides and stuff. I'm sure the peroxides wouldn't have formed because it's over sodium hydroxide, blah, 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 but I'm just overthinking it, but...
I mean, also, Tom, most people's dioxane isn't yellow either.
They do just have lumps of sodium lying around. I mean, they're under mineral oil. They're very bad lumps. There's a big block, but these are just small offcuts. You just cut into it. It is nice and shiny underneath, under all that crust, but the crust shouldn't matter either. Yeah, that bubbling there is any water getting destroyed, so... And that's good. Water is an enemy at the moment, so...
Most people drink water more often. True. They don't just piss straight into a flask like this, but... How else are you going to show that you're dedicated to your work? You have to be performative and dehydrate yourself on the job. So I'm, like, pretty confident that this is probably going to put his yield under what he needs.
Because there's still lots of sodium in there, and I don't want that to catch fire with
method acting.
Solvent.
Yeah.
That would be bad. This is our anhydrous
method
dioxane.
reacting, actually. He's a chemist.
In here, and I think together we're just going to be short of our target, which is both incredibly frustrating and incredibly bad, given that we started with a liter of ethylene glycol. We also have non-anhydrous dioxane. This is stuff that came over with the water azeotrope that boiled below the pure dry dioxane. So we could dry this out and redistill. It's roughly 20% water
give it a shot.
Dissolved in the dioxane. I've not nailed this synthesis at all. Really not nailed it. On a lighter note, long-time viewers know that I always like dyeing my condenser water green. I know, it's always been green. It's just always been green. I like it green.
Yeah, and it's full of mold, too.
When it's not green. Yeah, I had this bucket somewhere, and I tripped over it, and it spilt everywhere, and I forgot to dye it green. It's still moldy somehow, but
it's still fucking moldy.
Before I forget to make it not green again, importantly.
Bro really cannot be arsed to clean out his fucking water bucket. It's so disgusting.
Why this dioxane synthesis didn't work. The cooling water wasn't green enough. Obviously.
True. Okay. Green is a sign of good things happening.
In fact, I'll put more in.
If yellow is the sign of a chemistry reaction going bad, green is a sign of it going great. That's how everything works.
That would actually make a difference. I'm like, nah, I can't be bothered doing that. And I wonder why things don't work so well. I'm like the least scientific-minded person ever. I'm just doing all this science based on vibes. No wonder it doesn't work so well. Holy shit. Whatever, the condenser water's green. Moving on. 91.7 grams of dioxane, which is less than 110. Which means we're going to have to scale down the overall reaction. This shouldn't be our limiting reagent.
Tom, you could just do it again.
Let's just keep moving.
You could just do the ethylene glycol thing again. You can go to Bunnings and buy another 1 liter. They're not gonna, like, shoot you for doing so.
Reaction. Which, speaking of which, let's go check on the bromine. The next step really is to get the bromine.
I guess you don't want the bromine eating the cap either, so...
Where is our bromine? How is
maybe
our
you gotta get that done. Oh no.
All right, let's check on our bromine, which has been sitting.
Oh, you
in
can
this
you can already
whiskey here.
see.
I think
You could already see that the cooler is orange on the sides. This is not good. This is what we would like to call a bad omen.
esky is an Australian word. What do other people call this? I don't know. This box to keep the cold in. In here.
Okay. Oof. It's not that bad.
Importantly, the timeline in this
Oh.
is it's roughly 4 weeks ago.
Bunch of ice melted?
With Mr. Green. And bromine is reasonably corrosive. In fact,
Oh.
extremely corrosive. And even though it's sealed in this bottle here, we're still greeted with a somewhat unpleasant smell. Not overwhelming. Kind of the smell of mouldy piss. But none of the top notes. All bottom notes of mouldy piss. None of that ammonia sort of high-pitched smells. Just the good parts of the mouldy piss smell. How was that for an explanation? Bromine.
Oh boy. Child safety cap? Yeah, it's me, your good friend Richard Nixon. I bought the bromine this time. Child safety? No cap? Yeah. This is where that whole bromine explanation came in at the beginning. Why is this such a dangerous thing to work with? This is... Ooh. This is rough. Oh, but yeah, bromine... Fun fact, bromine is actually named after the Greek word like bromos or something that meant like wretched smell. Bromine, and I've smelled bromine before because there was actually one time where when I was in grad school, my boss came in and like had to make a little bit for like a thing that she all of a sudden really wanted to do. The fact that she actually wanted to do a reaction after months of not being in the lab and writing grants instead. And she didn't quite do everything right and spilled a little bit in one hood. And man, with just a couple droplets, did that lab stink for a few days. It was rough, even after most of it was cleaned up. Bromine smells awful. Is moldy piss the way I would describe it? Probably not. I would describe it as something between, like, wet mold and, like, rotten deli meat and maybe a little bit of, like, skunk juice thrown in there. Bromine is genuinely one of the most horrifying smell. Well, maybe not horrifying, but, like, it's like a top 3 worst things I've ever smelled, and it's like in a minute quantity. I've smelled it. It's not good. I could not recommend less. It's called bromine because of the smell. Yup. So we get a stronger smelling chemical, so they call it smash playerine. You'd have to translate that to Greek first, then it would become official. It's the Greek that makes it official.
Has corroded and stained this plastic orange. It, in the first 2 weeks, nearly
Although if you do want a smelly chemical synthesis, there is a chemistry channel on YouTube called Labcoats, Labcoatz. And they did a synthesis of what was purportedly the smelliest chemical known to man, thioacetone, which, from their confirmation, does smell bad, but no, it can get much worse. You can make selenium compounds instead of sulfur compounds. Selenium and tellurium organic compounds are, I guess to back up, like, the things that are typically smelly in nature are sulfurous compounds because, like, I don't know, sulfur is slightly available in a couple amino acids, and, like, the body just kind of metabolizes sulfur in a way where it's like, yep, these are waste products. And so evolution has trained us to hate sulfur. Selenium and tellurium are basically just big sulfur. They're the elements right below sulfur on the periodic table. And because they're not really common in nature outside of a couple of minerals, they aren't like in anything alive for the most part. The human evolution is not really like decreed a special like purpose for them. So the body just recognizes selenium and tellurium compounds as like extra smelly sulfur. And selenium compounds from that Labcoats guy report, they just smell like just straight up garbage concentrate juice. Like if you've ever smelled rotting garbage, a rotting dumpster on like a 90-degree day, It's like that, but worse. So, if anything, you might be able to name an organic compound after Smash players, basically. Big sulfur, like it's a corporate conspiracy. They want you to buy more sulfur, so that way you ditch big oxygen along with it. The mosquito diner story you had, yeah.
Completely got through one of these lids, which...
Oh, but yeah, see, look at that. It just like I was kind of pointing out earlier.
2 weeks, nearly completely...
Just when he was showing off the lid in like the look, we made a liter of bromine kind of thing. Yeah, that lid was in fact not having it, and you could still see that this lid was in fact not having that, and then you could see this lid on the right. Oh, it's also kind of not having it either. It's almost like bromine really doesn't want to be stored.
Got through one of these lids, which are actually very chemically resistant, and the bromine nearly broke through it completely in 2 weeks. So in this one, I've put a Teflon seal between the lid and the bromine, as well as
helped a little bit
because Teflon does resist the bromine, but of course the bromine works its way around the Teflon disc anyway, it seems, and has nearly broken through this second lid in another 2 weeks. Obviously, you can get better lids for this, but it does highlight the fact how difficult this bromine is to store. It's in this esky because for the first 2 weeks or so, I was buying a new bag of ice every couple of days and keeping it cold, which does keep the vapor pressure down. Obviously, you could think I could just take this bromine out and put it in a freezer, but given the way it's destroyed all this plastic and everything, you can
don't want to put the bromine in the freezer. You'll destroy your freezer.
Anything in the fridge and freezer.
Even if it is lowering the volatility, the slow fumes will destroy your freezer. You had a mosquito, so your mosquito dino story is that you had a mosquito that kept bugging you and your sister while you were dining out and talking about random shit. At one point, you yelled at the mosquito, "What do you know about Big Pharma?" And he fucked off. Oh, shit. You actually... So, apparently, hot tabloid news from Grimspecs. He has actually disproven the all birds are government drones conspiracy. It's actually all... Well, actually, no. He's just added on to it. The birds are... The birds are government drones. The mosquitoes are corporate drones. I'm 14, and this is deep.
Would take on this sort of moldy piss smell and be generally very unhealthy to eat. One interesting thing here, it looks like the bromine sort of collected around this neck of this plastic bag here, which used to have ice in it. But actually, I think there's a little tie and there's maybe some steel in it. The bromine has corroded the steel so badly that it's leaking all iron bromides in there. So there was one tiny bit of metal in this whole thing, and you can see how aggressively corroded it is in about 2 weeks. That's all the bad news. The good news is, look, hey, there's still 300 mils of bromine in here, so we have actually kept most of it. Even as difficult as it is to store, we haven't leaked out a third of our bromine or anything like that. We've kept it all in the jar. It's good to go. Well, not really, not in the slightest. We've got to do some purification.
The metaphors are so good, Grim.
The flask. We also have
it practically writes itself.
Here, so we've got to add some sulfuric acid to dry out the bromine. Make sure there's no water because it's got to be dry before we add it to our reaction. And then distill it again over some sodium bromide, which hopefully remove any chloride contaminants. I could store it in some glass. Obviously, the losses are going to be higher through a stopper or something like that. Or maybe a well-greased stopper was probably a nicer way of storing this, but I was worried about the lid getting shot off as the temperature got really high because it's been hitting.
Yeah, it's possible. You don't want to overpressurize in the hot Australian sun.
If it builds up in a flask and the stopper shoots off, then all the bromine will just be lost, and I would come back here to a very, very orange and corroded esky and be very sad about it. That didn't happen, so let's go on with processing the bromine. Hell yeah, we get to distill the bromine, which looks fantastic.
All right, actual bromine chemistry.
Not particularly pleasant to be around in real life. It's only me that has to suffer through fucking actually being here. So.
Oh, but yeah, no, the bromine distillation is dreadful. Because, I mean, part of distillation is that you actually have to have, maybe I can diagram this real quick. Oh, God. You have to have, like... So you have your one end here, and like it's connected to like your other thing with like your like temperature gauge up here. That was terribly drawn. Oh well. And like the glass ends up going like this way and goes towards your receiving flask. But part of it is that like... Oh, wait, God, what did he do? I just missed that. Oh, this aluminum. Oh. Nasty. I guess that's a way to to purify, to kind of clean off your waste. But anyways, yeah, so this receiving flask is like going to have an outlet. And so like inherently you're gonna be putting bromine fumes out into the world by doing this purification method. And so yeah, that's gonna stink. It's gonna stink. Bromine craft. Shut. But yeah, the sodium bromide should also help just remove that chlorine off. There's a slight preference for chlorine to want to be bonded to sodium versus bromine wanting to be bonded to sodium, so having that excess of bromine around will kind of help pull off remaining chlorines. But there he goes. Oh, yeah, I mean, he's doing the smart thing and not just, I can't believe it, not just putting more bromine fumes out into the world. Why he cares so much now after, like, you know, not having, oh, no, he's just putting it further away from him. Never mind. I thought he was putting it in, like, a scrubber to, like, reduce down the bromine. And afterwards, like in that bucket, to neutralize it. But no, he just bucket further away from him. It's fine.
But it's around 300 mils, and we only need 167.
Yeah.
Definitely more than enough. It looks pretty good. You can
His
tell
safety
bromine is reasonably dry when it knows.
His safety actually has gotten better over the years. He used to do everything in like jam jars with duct tape and like crappy tubing from the hardware store. But then he like actually got some money as he got older, so he could actually use real glassware.
No longer start sticking to the glass. You can see how it's running off that glass there. If it's really wet bromine, it kind of sticks to the glass a bit more. It's not perfect, I would say, but it's pretty good. That's fantastic. So we've actually completed the whole set. I was actually
the family's back together.
Scale down because of
the gang is here.
That I went back, re-separated out some of the azeotropic dioxane.
How much you want to bet that he's going to have extra bromine that he's going to let sit around and eat through another cap?
Just over our required 111.
Oh, wait. What was he talking about?
Now, can you believe it? After doing it again, we have 111.5 grams of dioxane, which is just over our required 110 grams.
Oh, I think after you combined everything.
The limiting reagent here, because
that's good.
We've got more than
is that to scale his stuff down?
130 mils of ketal, but it's fine. We'll do it on the scale, so we're going to use all this dioxane, pretty much most of this ketal here, half of this bromine, and I think majority of this DCM. Let's not delay any longer. We've got a long reaction to do. Let's go. Let's get this set up. Okay. 3, 2, 1, set up. Go. Ready. Wow. A perfect jump cut. Look, this is the setup, and I was going to go through and fill this all up and talk you through it, but look at that temperature gauge. Temperature is very important for this reaction. It was 39 just earlier. I know there's no solvent in there.
They're going to get a digital temperature gauge.
About 40 degrees. And we're going to have to churn through so much ice to cool this down. And doing temperature...
That's also something that fucks with his reactions. The fact that he lives in Australia and it's always like 40 Celsius outside in the summer. That tends not to be good for your reactions. Room temperature is usually defined as 25 Celsius. A cool 70-ish Fahrenheit.
The point is, I've just set up this entire somewhat grotesque setup, and I'm actually just not going to do the reaction today at all. So we'll come back another day when it's not fucking 40 degrees. Holy shit. Look, there's some clouds these days.
Wow, clouds.
Should be cooler soon.
You don't see those in the southern hemisphere that often.
Okay, here we are. It is much cooler. I had to wait about a week for the weather to actually cool down, but the room temperature is only about 20 degrees. So here we are. Here's the actual setup. We have everything in our flask as needed. We've got about 500 mils, which is a little bit skimpy of DCM. I don't know, I'm always just a bit skimpy with solvent, but that's fine. Then we have our cyclopentanone ketal in there, as well as our dioxane. Obviously, up here is our bromine. We have some argon coming through from the argon cylinder. This is probably not needed, but
let's see.
You know, this argon cylinder is just from the hardware store for use with welding, and that's coming through very slowly, coming through the top. The argon is coming out here and just pushing through a little bit of water, because this reaction does generate some HBr gas, which we can't just seal this up and let it get pressurized, because that would be a very bad idea. But we also want to keep this reaction
hydrogen bromide, the heavier cousin of hydrochloric acid.
Back in there, air and moisture from the air. So this argon kind of flowing
even more
through
deadly.
We'll keep it dry. We are using DCM as a solvent, which I think will dissolve quite a bit of the HBr, so we don't expect a lot of outgassing, but this should still control it. Most other people would run this reaction with dioxane as a solvent, so you just use, say, 5 times as much dioxane, so then it's the thing that reacts as well as a solvent, but obviously you've seen how much I struggle getting dioxane, so the DCM lets us, you know, once again, skimp out on the dioxane. It's all about skimping, I suppose. It's a bit of a weird setup here. This is obviously a takeoff adapter for a distillation. Very weird for it to be used in this circumstance. I'm just using it because I can't find my Clistand adapter, so there's better adapters for this, but that's fine. This is definitely
any glassware will do.
This is Teflon tubing. This is Teflon coming in here. Yeah, this is obviously fitting a temperature probe in there. It's currently reading at 3.9 degrees Celsius, which is great. This is on the cooling bath. Obviously, I could just use an actual thermometer and do this a little bit differently, but I like having the thing here for the camera, so it's kind of sealed with this Teflon tape, which is a bit sketchy, but anyway, and through this bit of broken glassware in here. It's fine. I've got a sort of a sick perversion to
he has broken glassware somewhere.
Sealed with this Teflon tape, which is a bit sketchy, but anyway, and
terrible
through this
taping.
bit of broken glassware in here.
Oh,
it's
it's just
fine.
in his
I've got a
adapter
sort of
he
a
didn't
sick
clear.
Perversion.
Didn't want to clean it.
Broken glassware. All right, let's talk about temperature, because we're obviously doing this on a cooler day, and we've got all this ice here. So what's up with temperature? This is the Navy report from 1989. Goes through this sort of big scale reactions, and it does it on a really, really large scale. Some of them, like here, it's 68 kilos of cyclopentanone, which is huge
it's like
scale.
industrial size.
Huge industrial scale. But they do sort of what I would say a medium run, which is about what we're running the scale on as well. So we're following mostly this paper. This paragraph is of particular importance. The analysis of the bromination was followed. At the completion of the bromine addition, the reaction was found to be 1/3 complete. The second and third bromination steps proceeded very slowly at 15 degrees C, but required 16 to 18 hours at 20 degrees C and only 2 to 3 hours at
all
27
within 10 degrees
C,
Celsius.
which is great,
Crazy
because
variation.
That means we don't have to be here for that long. However, it continues. When bromination reactions were heated above 30 degrees for even periods as short as 10 minutes, extensive decomposition occurred and only tars were obtained upon dehydrogenation.
We love tar.
Which is the next step. So, if this reaction goes
hey,
above
Chris,
30 degrees
I would
for even a couple of
I would
minutes,
recommend removing the
lost.
tinfoil hat, because if you have the tinfoil hat on, let's see, hold on, what time am I at so I can come back to it? 32:50. You have your tinfoil hat on. This might happen if it gets exposed to bromine fumes.
What was Mr. Green's motive? Well, I mean, you might guess that he just wanted to make a very big bromine volcano.
You don't want that happening to your head, do you?
The aluminium. He'll make a video up on his
maybe
channel about
just opt
making
for
this big
a
bromine
standard hat.
vortex, but
Hey, it's nice to see you here, though. Nice that you could make it. We're currently in a step where he's made all of his bromine and all of his other reagents, and he's doing the reaction that I've drawn here on screen. I would, I guess the basic explanation for it is kind of like back with this explanation I did a little bit ago for oxygen. You have these. Oxygen has unpaired electrons that want to pull off these hydrogens from carbon-hydrogen bonds and kind of insert themselves into the structure, but in a slightly different way. Bromine just has a very unstable bond that would be fine breaking itself up to attack carbon-hydrogen bonds, have electrons kind of move around like this a little bit, and then ultimately the bromine kind of comes back after multiple steps to form carbon-bromine bonds and some HBr. And so that's kind of ultimately, roughly what's happening to get to this product up here. The dioxane is necessary, apparently, because it's like a good catalyst. I'm not sure why. Even my chemistry knowledge is not completely in tune with this, but it's something that's like the dioxane reacts good with the bromine and like makes a carbon-bromine bond that like wants to exchange with like these carbon-hydrogen bonds better than regular bromine can. Or maybe it also just kind of maintains bromine in like the solution better without causing it to just blow everything up to smithereens, metaphorically speaking. So that the dioxane matters for that reason, for some reason apparently.
everything is ruined. When we were considering doing the reaction the other day and the room temperature was 39 degrees, that's very bad. So we have to have very good cooling here.
If his reaction's too hot, it just turns into tar.
At large scale
tar.
as well in proper laboratories, and they say stirring was very important. So we've got a bit of a weird tower here, which is a little bit unsettling. We've got high stirring, so when the bromine comes in, it should stir very well, which will help with cooling. Yeah, this temperature control is very important. How do we start it? The addition of the first mole of bromine was accompanied by a large exotherm, and it was necessary to cool the reaction mixture with ice water to maintain the temperature below 15 degrees C. So after half the bromine was added, hydrogen bromide gas was evolved at such a rate that the mixture spontaneously cooled. So
cools that much, but I guess releasing gases would
was on a much smaller scale, and these sort of
would probably release some energy just because it evaporates. Evaporation takes energy away. That's why sweating cools you down.
1 mole of ketal, 3 moles of bromine, and approximately 1 mole of dioxane in methylene chloride, this is DCM, gave yields comparable to those in dioxane solution. Fantastic. All right. Shall we do it? Let's do it. Hell yeah. Let's go.
Now the pretty part of chemistry, watching the reaction take place. This is the kind of thing that's like, this is the weirdly aesthetic, oddly satisfying thing for me. A lot of people like watching people mash slime together on TikTok. I enjoy watching people mix deadly chemicals to make cool looking fumes. I love fumes. I mean, it's kind of mystical looking, you know? It's kind of got like that magician's orb kind of feel to it. Oh yeah, and then like a good chemist, he's actually, you know, neutralizing the hydrobromic acid coming out as a side product instead of just letting it go out into the atmosphere. Boom, 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 boom. Boom, boom. Right. Look at that bromine flow. I love how thick it is, too. It's just so satisfying seeing it kind of trail down the glass slowly and then just heavily drop to the bottom. Alright, now the challenge. Can Tom keep this reaction underneath 30 Celsius? Or is it going to spike and just completely just turn into crap? Oh, he's really pushing it there. 27.
Everything went really well.
Ooh, you got a maximum 27. Shit, nice.
To try and purge as much of this HBr gas out of the reaction as possible. It's been stirring at 27 to 28 degrees for 2.5 hours, maybe close to 3 hours actually. We've probably completed the bromination. So, how do we get our brominated product out of there? Well, first of all, we've got to get rid of all this HBr gas.
I thought that was like a rat moving across his floor for a second. No, it's just his garbage.
Sodium sulfite, which will destroy any remaining bromine, and then finally add some sodium hydroxide.
Would I like this kind of equipment in my house? I mean, admittedly, I kind of am a little bit envious. I do have a little bit of glassware of my own. I've done some like milder experiments, but like, I would like this equipment, this glassware, and all this other stuff in my hypothetical home if I had space for it, and if I had a good fume exhaust system, a fume hood in my hypothetical like mansion, but that like costs several $100,000s. I am not crazy enough to work with bromine at home. That would be just a dumb, stupid, bad, dumb idea that would result in me like melting my face off or like dying of like brown fume inhalation. Not good, but like this is kind of cool. I do kind of like it. I love having chemicals around the house a little bit. It's kind of, I don't know, it's just nice.
Brominated product out of there. Well, first of all, we've got to get rid of all this HBr gas. We've got to slowly add some water and then we got to add some sodium sulfite, which will destroy any remaining bromine, and then finally add some sodium hydroxide and sodium carbonate, which will react
neutralize all
with
the
any
acid.
of HBr and neutralize it. So once we have that, we have the water layer and the dichloromethane layer. We'll take the dichloromethane layer out. We've got to separate it off, which is a little bit difficult because there's so much of it, and there'll be quite a lot of water as well. But once we have that by itself, without the water layer,
it's a good amount to work with. At the very least, you won't have nothing.
Distill the dichloromethane off to be left with a residual oil. Should crystallize out into our tribromo product. We're distilling it once we've removed any residual bromine or hydrobromic acid. It should really be an issue.
His like little trap in the corner here for like the hydrobromic acid gas coming out of this. Like, please, dude, use a bigger beaker. That's like that is easily just jumping ship and jumping right out of the beaker and splashing everywhere. It's just looking at that gives me anxiety. I don't know if I've ever watched Mr. Bean. A little bit. There's an episode where Mr. Bean goes to the school and explodes the entire chemistry room with blue substance. Blue. I can't think of any strong blue explosives, but actually no, that's a lie. I can. Any copper nitrotetrazoles. Those are big blue explosives. Maybe he was a chemistry expert. He made something that most high school chemistry teachers would not be able to do. He just maybe made a bit too much of it.
Residual bromine or hydrobromic acid. It shouldn't really be an issue with heating it to 40 degrees, even though we've just spent the last couple of hours.
My arms are stiff. I just tried to pop my arms and they cracked like a 55-year-old man.
So hopefully, yeah, just running a normal distillation is fine for it.
Alright, ice cubes, get it nice and cold. That helped all the salts kind of come out of solution, all the side crap. Also makes the oil and water layers separate a little bit. Now I can put in some like salt solutions. The sodium sulfite reacts with any excess bromine, turning that into a easily separable salt. The sodium carbonate neutralizes the acid, making it less caustic and safer to work with. Now he's separating out the organic and water layers that are insoluble in each other, kind of like oil and water. Distilling off DCM. And getting rid of all the extra solvent so that way he can actually isolate his product and recollect the solvent for later use. That shit's expensive when you're a home chemist. Poor kid with the glasses, the blue substances all over him. Oof. Oof. He needs to go use a safety shower then. He needs to rinse himself off. And probably sue, honestly.
I'm going to try crystallizing it out using some seed crystals from this.
So for anybody joining, he did do this reaction a long time ago, many years ago on a much smaller scale. And he did keep a little bit of his kind of like crappy medium purity product with him. And so what he's going to try to do here is recrystallize the product. Recrystallization is a common method of purification in chemistry where you have a solution that's like full of your like product molecule. And let's just draw like triangles, say. So like your product molecule is like your triangles. Product. And then you have a whole bunch of other like squares that are like your impurities. So we'll just say squares equals crap. That's a scientific way of putting it. Oops, wait, I changed tool on accident. Okay, there we go. And so by crystallizing your material out, you can basically leave a solution that still has all of the like squares and the crap still in solution, but you can have your triangles kind of your product solidifies out with relatively few impurities inside of it. And getting something to crystallize usually takes either making it cold and hoping that it becomes less soluble in the solution, and or putting in a seed crystal, which actually that might be a better arrow to draw separately. Draw a seed. which would basically be the equivalent of dropping an extra triangle into this. Which then kind of basically goes on to just give all the other triangles like a scaffolding to base itself off of. So he has some old crappy product from the last time that he made this, and that should be enough to kind of get things going and leave some of the garbage that he doesn't want behind.
Old tribromo ketal we made last time we did the synthesis. There's not very much in there, but we should only need a couple of milligrams, a couple of seed crystals, hopefully trigger it to crystallize out.
I actually had to kind of utilize this in my research at one point because I had a product which only actually came out of a very, very thick, oily solution after 2 weeks of leaving it alone. I had went on like vacation or something. I can't remember why I left it for 2 weeks. Usually I didn't do that to my and then it made the product. It actually came out finally out of solution. But later on, when I was doing the reaction, I didn't want to wait 2 weeks every time I had to like remake the product for my research. So instead, what I did is I just kept a little bit of the first batch, and I was able to drop like just like a little milligram into the thick oil that I would get. And just after a little bit of agitating that, stirring it around for a little bit, it kind of turns into crystals within a couple hours, a couple minutes actually. It's really nice. Oh yeah, look at all that. All that delicious solid he's getting. It's actually pretty good. Last time his solid was like brown, which is not a good sign typically for most organic reagents, but look at all that. That's a pure white substance. You could publish that. That's great. I think that's way better than last time.
With 170.8 grams of this dense powder that kind of has an off-putting smell of sickly, moldy carpet, but not a trace of the color yellow in here. This is fantastic. Not even a recrystallization needed. It looks perfect.
Oh, well, and that's like that very abrupt end of the video, but yeah, no, he like that is probably one of the best products he has ever made. I'm trying to get a good still frame of it. But, yeah, no, I don't know. I had fun. I'm happy to see that. I think this was, in fact, a good time. I'm going to just kind of cut stream short. I'm a little tired anyways, but, like, thanks for joining me here and enthusiastically watching a man mix hazardous chemicals together. And hopefully the science that I explained along the way helped to make it digestible. You know, I recommend Explosion&Fire / Extractions Ire channel to anybody watching. There's plenty of more fun shitposty chemistry to be had if you're interested at all. But I think that's going to be it for me tonight. Next week, we're going to be back on Monday and Tuesday with Magmammal, or not Magmammal. Boy, that's a long time ago. Mega Man RPG, and more Doom TNT Evolution. I will also hopefully be posting my poll this weekend in the Discord chat and the YouTube YouTube polls for when to have the 100 subscriber special, so be on the lookout for that. I'm planning on doing that in 2 weeks from now, or 2 Mondays from now, so you know, be sure to vote on when you can actually make it, because I'd like everybody possible to be there. But that won't be at least for another 2 weeks. So, yeah, have a good night. Thanks for joining me and humoring me in my chemistry enjoyment, and I will talk to you all later. Bye.